Can you hear me all right? Okay. I'll try not to sing. Whoa, go with me now. It's the only dance move I have. All right, welcome everybody. I say welcome everybody. Hi. So this is the Power 3 Instant Clones App Volumes UEM. I'm Rick Watson. I'm the presenter here today. I've been working with VMware's end-user computing technology since the very first version, so I think it gives me a lot of perspective. So what we'll be talking about today, instant clones, user environment manager, app volumes, and then we'll wrap everything up and have questions. So, man, is it hot in Vegas, right? How hot is it in Vegas? Last night I saw two hobbits throwing a ring into the volcano over at the Mirage. Yeah? And I think maybe though they were a little confused because they said something about they had found something better to smoke than Old Toby. Something about Girl Scout cookies or something. I don't know. Anyway, so yeah, it's been pretty hot, and pretty hot are these technologies. They make up what we refer to as JUMP. Okay, so what JUMP means is just-in-time management platform, and it gives you ultra-fast provisioning of your desktop operating systems for your end users, gives you real-time delivery of applications, and policy management that is very powerful and dynamic. All right. Now, first thing we'll talk about is instant clones. And so first question would be, what is an instant clone? Well, like all other clone VMs, you start off by making a master golden image of Windows. And then in Horizon, you select that you want to create multiple copies of that. You know, you want to create a pool. All right. So during that process, a virtual machine is created on every ESXi host that you specify you want these instant clone VMs to run on. And that VM boots up and then is suspended or quiesced. Okay? And from that VM, we create a child VM. Now this child VM uses the memory of the parent just like we do with link clone OS Delta disks. It uses it as a read source. So that child VM, it is created in less than a second. It doesn't boot up. When the host gives it CPU cycles, it's already up and running. So it eliminates all the overhead of getting a VM, an operating system and a VM booted up and running. Okay? A process that we call clone prep changes the Active Directory name of that Windows VM, and it's available to the user to log on in about 3 to 5 seconds. So the entire process from no VM for that user to having a VM ready for them to log on to as little as about 5 seconds. So maybe when we said instant clones, you know, we oversold it a little bit, but it's pretty close. And you can do this dozens of times on each ESXi host. So you can very quickly provision dozens, hundreds, thousands of VMs. Right? Now the other thing about instant clone VMs, they're not intended to be persistent. So when a user logs on to this VM, they use it. When they log off, Horizon deletes that child VM. So we don't have to keep copies of Windows floating around. All right? Now, there's certain requirements in order to have and use instant clones. The first one, you have to have Horizon 7. You have to be using vSphere 6 U1 or higher. Your master VM has to be built using virtual hardware version 11. And we support Windows 7 and 10 VMs and don't support Windows 8 VMs. And you must use distributed virtual switches with static binding. We don't support ephemeral or dynamic binding. Okay. Architecture-wise, if you're familiar with Horizon and Composer and link clones, you need to add a database, you need to add another server. None of that is required with instant clones. There's no server, no additional database. Everything happens within the Horizon connection server, and it communicates with vCenter server to manage the instant clone VMs. Right? Instant clone VMs support all the vGPU capabilities, particularly on Windows single user OSs, like Windows 7, Windows 10. Now there's some limitations. We only support the NVIDIA M series cards. We only support Blast Extreme officially. PC over IP is considered tech preview. And as I said, we only support this for desktop OS VMs. All right. However, you can create instant clone remote desktop services Windows VMs, and for example, you could use that for application pools or user desktops. So you can really quickly scale your deployment of remote desktop services, or your updating and transitioning. Instead of having to worry about having maintenance windows of hours or days, you can have maintenance windows of minutes. Right? Now, there are some limitations. Current version of Horizon 7.2, you're not allowed to have dedicated assignment to the end user, and we don't support IP version 6, but a little tidbit that I don't know that's out publicly yet, in Horizon 7.3, those two things are going to be available. Okay. Currently, the other thing that occasionally is asked for, it's a very limited corner case, is sysprep support, and that's on the roadmap, but no official date for that yet. Okay. Now, when you create an instant clone, there are several steps that occur that we refer to as priming. The first thing is you have your master VM and you shut it down, you take a snapshot. Same thing if you're familiar with Composer link clones. From that, a virtual machine is created that we refer to as a template. What this virtual machine, the primary purpose for it is, it joins whatever domain you specify you want these VMs to be placed in. Okay? Then from that, we create a replica. The replica is a full copy of the template, therefore it will be in the domain, but we then provision the disk. So if your master VM had, say, a 40 gig disk, but only 10 gig of it had data on it, your replica will only take up 10 gig because of the thin provisioning, so it saves disk space. Now we put a replica on whatever data stores you designate that this pool's VMs are going to be stored on. All right, if you've worked with Composer and link clones, this should all sound pretty familiar, right? Okay, well here's where things get a little bit different. With instant clones, on every host, a parent VM is created and booted up and then frozen or quiesced. Now, if you're familiar with Composer, the parent VM is a link clone, all right? Then, this is where the magic happens. To create the instant clone VMs, using a technology we call VM fork, the instant clone VM is created, and we don't use an entire disk. We use OS Delta disk, which this link clone, link disk that's listed there essentially starts out at 0 size. Okay? But the other thing that we do that's unique is we use the concepts of transparent page sharing to make the RAM of the parent available to the child VM, and so we don't have to write every page of that memory. So at that point, the child is up and running, and it is a unique VM. The clone prep technology changes its computer name in the Active Directory domain, and the user can log on. And if the child VM needs to write any changes to disk, it and the parent both read from the replica. It has its own OS Delta disk that it writes to, and then the same thing for the memory. It has its own active memory that it writes to, but it's reading from a copy of the parent memory. All right. So, in summary, with instant clone VMs, or at least summary of instant clones, It leverages what we call VM fork technology, and it avoids the boot up resource overhead of deploying VMs. Okay? It works with both single user operating systems and remote desktop services, and there's no additional database or server required, and it's also a much smaller workload on the vCenter system. So that's our first of our three technologies we want to look at. The next one, User Environment Manager. If you're going to have a copy of Windows you're providing the user that disappears when they log off, well, what's going to happen with all those settings they make, like putting their favorite background screen or choosing their defaults and applications? Well, this is where User Environment Manager comes in. What User Environment Manager does, in a typical Windows system, like we're showing here, the settings for the applications and the operating system are all very tightly integrated with that specific instance of Windows. So what User Environment Manager does is it captures those settings and saves them. Things like the personalization, the application configuration for the different applications that are running, the environment settings, and so forth. Okay? Now, the way this works, the architecture, UEM doesn't care how that Windows is running. It can be a virtual machine. It can be a physical computer. It can be a remote desktop services session. And when I say virtual machine, I mean any virtual machine, any kind of virtualization, not just VMware vSphere, although I don't know why you'd use anything else, but just if you were. So on whatever those endpoints are, you install a UEM client or agent. And what that client or agent does is it gets a configuration from a shared folder. So you define how you want UEM to behave on these systems, in files in that folder. You can also set a base configuration for specific Windows settings and specific applications. There's also, UEM creates a unique folder for each user, and all that configuration that the user does, changing their background, changing their screensaver, changing their preferred font in an application, all that gets saved into a folder that's specific to that end user. So what that means is that user can move from one copy of Windows to another, that as long as they have the UEM client on and are pointing to the same configuration, their settings and their choices will follow them around. And this includes not only that, but it can do things, the folder redirection, like we've done with Windows in the past, can be handled with User Environment Manager. Okay. Now, there's a little setup to get this going. So we have our systems with the UEM client or agent on the left there, and the configuration share and the user share. To define the configuration, you use an application, a UEM management console application. You doesn't say the word server. This is just a tool that you use to define the configuration. And it also defines the share. So that information is pushed down to the UEM client systems using Active Directory, using group policy. Now that's up to version 9.1, as I recall. In 9.1, 9.2, we also added a capability we call no AD mode, and in that case, a script on the client or the install of the client defines the configuration share, and Active Directory is not needed. Okay? So if you have an environment that's either no AD or maybe there's some conflict with over what can be done with group policy, this is a way to get around those issues. All right, so now that the systems with the UEM client or agent know where the configuration share is, they can pull a configuration down from that share. That defines for them where the user share is, and UEM will create a unique folder for each user on that user share, which that user share is also called a profile archive. Now, I don't know if it jumps out at you here, but there's no UEM server, there's no database. The whole infrastructure for this is shared folders. So it scales tremendously with the existing resources you have. And you don't have to point every user in your organization to the same configuration share. You can have different configuration shares for different departments or divisions or even groups in your organization. So it scales in that way because you can have different configurations for different users, or you can have different shares just to handle the workload of thousands, tens of thousands, hundreds of thousands of end users. Okay. Now, in that user share, what is stored is a series of files. And here you see a screenshot of the management console for User Environment Manager. And each one of those icons represents a separate file stored in the user share. Here you can see files primarily for applications. Excuse me. Okay, so each application's configuration is stored in a separate file. For Windows settings, which are a little bit further down in the interface, the same thing. For different types of Windows configuration, each setting is stored in a different file. Okay, so you can create predefined settings from that configuration that will be loaded. So you can have the environment configured in a way it makes it easier for the users. You can also make those predefined settings mandatory. So let's say, for example, your institution security policy requires a password-protected Windows screensaver. You can enforce that with a UEM setting. The user can try to change it, but it won't save that change. But you can allow them to change all sorts of other settings. So UEM kind of brings the best of both Windows roaming profiles and Windows mandatory profiles. Okay? Another thing about these settings, specifically for application, they don't have to be loaded every time the user logs in. So unlike a Windows roaming profile where everything has to be pulled down at logon, settings for specific applications can only be pulled down when that application launches, which we'll see a little more detail of that in a moment here. I mentioned the predefined settings you can create. Also, there's a help desk tool that you can allow specific, administrative personnel in the organization, help desk namely, to access users' profile archives to troubleshoot. They can restore backups that are created automatically. They can reset settings back to the default levels. Okay? So this helps make your users more productive by not having them stuck because they've made a misconfiguration that makes an application unusable for them. All right, so here's how it works. We mentioned that the UEM agent pulls a base profile at the initial logon from that configuration share. Okay. Then any user-specific settings are pulled down, specifically Windows settings. Okay. When an application launches, the settings for that specific application are pulled down, and as the user uses that application, they make changes to the configuration. When they exit from that application, in this case an Adobe application, the settings for that application are stored. So you notice all of the configuration isn't pulled down at log on, and all of it doesn't have to be written at log off. At log off, any unsaved configuration settings are saved. All right. Now the other thing that makes UEM incredibly powerful is you can evaluate conditions of the UEM client system and apply or not apply settings based on those conditions. So for example, you can look at the IP address of the system or what Windows version they're running, group membership, the day of the week, and many more as you can see in the list there. You can also combine those conditions. You can combine them. We have the AND operator, we have the OR operator, and you cannot either one of those. So in the example there, you can see there are three conditions we're looking at. UEM processes those from top down. So the first thing it says, well, if the IP address is in this range and the operating system is Windows 7 and the user is a member of this group, then do whatever this is. Apply this setting, do this task, so forth. So unless that UEM client system meets all three of those, this particular setting won't be applied. You can also use ORs and, as I said, not. So in this case, it says if it's IP address in this range or the operating system is Windows 7 and not, the user is not a member of this group. So you can have very complex evaluation of conditions. This one might be a little bit, going to the way overly complicated example, but it gives you an idea of how much flexibility there is. All right. Now, speaking of Horizon, User Environment Manager understands Horizon, and you can use it to add these conditions to Horizon policies like USB redirection and HTML file transfer and the clipboard and printing and client drive redirection and your bandwidth profile for Blast Extreme or PC over IP. So you can see there in the screenshot, you can define which of the Horizon settings you want to modify and in what way. And the first example there, USB redirection, is set to disable, but you can also add those conditions. So what you could do is say, well, if that client is connected to the corporate LAN, allow them to do USB redirection, but otherwise don't. So you can define, those kinds of scenarios. All right. Another really powerful feature is something we call application blocking, which is a little bit of a misnomer because you can actually block or allow applications to run. And so this would be a scenario, if there's certain things you don't want the users running, you could block it here, and that's what this example is. So we enable a global configuration, we set the conditions, so using those conditions we talked about, we define when this is going to apply and what scenarios, and then we can also define the application. You can do it as simply as browsing to the executable. You can do publisher-based policies and allow all applications from a certain publisher or block all applications from a certain publisher. When the application is blocked, the user gets a message, the application is blocked, and you notice the bottom right there, it's also logged in the UEM logging, so you can look back and see that. Especially if you've got a great tool like vRealize Log Insight, it will go out and give you a whole report of how often this happened and what the application is. Now you can also go the other way. You can allow applications. So there might be an application that Windows settings on a lockdown desktop doesn't allow, but you can use a UEM to allow that. Okay? I'm trying to not sound like an infomercial, but wait, there's more. Well, another amazing feature, privilege escalation. You can use this to allow the end user to run or install an application that their Windows permissions wouldn't allow them to run or install. And so it gives you the capability, for example, for the running, a lot of legacy-based applications that maybe require higher administrative rights. For the installation, you can create a repository of installation files and say, I want them to allow them to install these. So even though their Windows permissions don't give them enough administrative authority to install that application, you can do that. So you select what applications this applies to. All right. So like I was saying, User Environment Manager, it is incredibly powerful, but it is also incredibly scalable. It requires 2 shared folders, and you can spread that across multiple copies of that, what we call multiple environments. So it scales to tens of thousands, hundreds of thousands of users extremely easily. All right, and the last of our 3 technologies we want to talk about is app volumes. So traditionally, applications and their settings are very tightly integrated with Windows. And what App Volumes does is it puts a layer of abstraction between Windows and the applications. Same concept as what vSphere does between hardware and the operating system, in the virtual machine. Right? Now the way it works is you have a VM that has the App Volumes agent installed. It's going to have a C drive that it boots up and runs from. Well, the App Volumes agent lets us point that VM to virtual disks that have one or more applications installed. We refer to those virtual disks as an app stack. So in this case, there's 3 app stacks there. And the operating system, the Windows runs those applications. The user doesn't have to do anything. It's totally transparent to the user. Okay? So in more detail here, you have the operating system, the agent installed, and the app stack connected. That app stack has specific applications on it, and the App Volumes agent makes this look like one seamless file system, one C drive. So you can deploy applications to any instances, Windows VMs, whether they're desktop OSs or RDSH VMs. All right, so to create the app stack in the App Volumes Manager, what you do is you select that you want to create an app stack. It makes a copy of an empty VMDK file. Okay? The App Volumes Manager asks you to choose a virtual machine. You choose a Windows VM. It connects it to that disk and installs the applications. And once you get all the applications you want on that app stack, typically you're going to put several related applications on there. Once you get them installed and everything's working correctly, the App Volumes Manager separates that app stack from the provisioning VM, and you can deploy it to the end users. With apologies to Chester Cheetah, it's dangerously easy. Okay? All right? Okay, so the big picture architecture of App Volumes, you have your endpoint system, Windows system, VM, with the agent installed. When the user logs on, it communicates with an App Volumes Manager system. The App Volumes Manager system has a database that it looks up that user. It talks to Active Directory, gets that user's group memberships, because you can assign these app stacks based on not only user, AD group, even OU, right? But once the App Volumes Manager figures out which app stacks that user should be given access to, it asks vCenter to connect that system, that VM, to those app stacks, and the user can launch those applications. And this whole process happens in seconds, 2-3 seconds in the background, right? Now, sooner or later, you're going to need to patch or update an application. So, what do you do in that case? Well, using that same provisioning process I described a moment ago, you go back to the app stack, you update whatever application or applications, and then you can assign that updated app stack to, users, and you define whether that app stack replaces the original one immediately or at next log on. So, usually you can have your user switch from an old version of the application to the new version just by exiting and relaunching the application. But you can also specify to wait until the next time they log on to make that switch. All right? Now, one of the issues with instant clones you might run into, the app stack disks are read-only, and the C drive of that instant clone VM might be deleted at logoff, or if it's an RDSH session, they're not necessarily going to get the same session or even on the same host. So App Volumes gives you a mechanism so that you can give a writable disk to your end users. It's called Writable Volume, and it's a read-write disk. And if you're familiar with the concept from Composer and Link clones of persistent disks, this is very similar. This writable volume is allocated to the user, and as they switch from one, in one copy of Windows to another, it's going to follow them around. That writable volume still looks like the App Volumes agent, make it look like it's all part of the same file system. There's no hoops that the user has to jump through. It's totally transparent to them. Okay. Now, that writable volume, one thing that's different about it, the app stacks can have dozens, hundreds of users using the same app stack, but a writable volume is dedicated to a single user. And there's two ways you can deploy it. You can deploy it one way where users can save data to it or potentially even install applications, especially if you allowed that with the UEM, privilege escalation. Also, you can deploy it and have the user's profile folder redirected to it. If you're using User Environment Manager, though, we recommend that you do that with User Environment Manager and just use Writable Volumes if you need to give the user a place to save files or install applications. Okay, so in conclusion, jump architecture, to me, it fulfills the promise that VDI has held out since a decade ago when VMware first started making it available. It gives you all of the advantages of having a non-persistent operating system, but the user has that perception that they have a persistent copy, that they use the same copy day after day, even though it maybe only existed for the last 5 seconds. So with instant clones for desktop OSs and RDSH hosts and app volumes for providing applications for your end user Windows systems, and also application pools and using instant clones, your RDSH hosts and User Environment Manager. Those three things, those three major things, fulfill that promise. And we talked about the power of these three things. So I'll leave you with one piece of really good advice from an famous and wise philosopher that you may be familiar with, who said, "With great power comes great responsibility." Right? Okay. So if you want to learn more about this, while you're here at VMworld, you can go to other sessions that talk about instant clones, like there's an Instant Clone 2.0 session, I think it's tomorrow. There are sessions about app volumes and UEM. If you want to go a little bit deeper than that and spread it out, VMware training on these options, both in person and online training. All right. Also, if you're already a guru and you want to take a certification exam upstairs, we're doing certification exams, okay? 50% off. All right. So thanks for your time and your patience, and remember to fill out your survey. And so if you have any questions, I'll be around to answer them. But otherwise, again, thank you, and I hope you enjoy the rest of the conference. Thank you.
Tomorrow, how do we sign up for that?
The instant